Hello, my name is Corey Heisey, and I'm taking my master's in mechatronics and cyber physical systems. Today I'm going to go over a few little projects I went over with an Arduino board, Arduino Uno. Didn't really build anything, but I was just kind of playing around with it and messing around with some of the parts that are in the kit. And so I did electric motor, just a DC electric motor that comes with the kit, hooked up to a transistor, and then you can control the speed and the acceleration and how long it is from the code. And then I have, I was trying to make a tachometer. Didn't really work out, I'm missing some parts, but I was able to hook up the infrared emitter and infrared receiver. And so what it is, it's supposed to have a infrared sensor module. So it has the emitter and the receiver next to each other with like an op amp and a resistor, and it's like a proximity sensor. Well, it is a proximity sensor, but you can set it up to calculate RPMs, but I don't have that module. So I just took the receiver and the emitter, and so I was in the code, so you flash it like with the remote or with the emitter, and then it'll output an RPM. So it's just arbitrary, but I mean, I get that. I'm getting the idea of it, right? And then I have a temperature and humidity sensor that I made with the kits, or what came with the kit, and it reads the temperature and humidity, which is pretty cool. Instead of, because a lot of the stuff had you do serial.print in the code, so it prints it to like an output in the code, but I wanted it on the screen, which is just a bit more user friendly, I think. Then I have a proximity sensor with like the ultrasonic proximity sensor that came with the kit, and got that working, and it's in centimeters and meters in displayed on the screen. But the only problem is I think when it doesn't read anything, so if it sends a signal and doesn't get anything back, it'll say like 23 meters, which must be, it's like max. So when it's on the table, it could see like it could get the roof, and then hand over it or something, it would get it. But if I move, it would have the max. Anyway, so but I think that's just part of it. There's not much you can do about that, I guess. And then I did a light sensor. So it's a little component in the kit LDR light, I don't know, whatever, and hooked up to the Arduino and a resistor. You can go on to this. So when you go into the computer on the Arduino IDE, you go serial plot, and you can see a graph live. And I flashed like a flashlight in front of the sensor onto the sensor, and it would show the spikes, start turning the lights off, and it would go down. So it's some good live feedback, which is pretty cool. Yeah, I was gonna do like a video each of this, but I decided it's not really that too much to it, so I decided to put it all on one video. And then I might try to build something, like actually build something that it would be better content for a video. But I figured just little running more wasn't great. So, but I think I have like 5 or something little projects with these components. So I have a bit of video of the component working and some screen casting. So I'm gonna so you'll stay tuned for that, and you'll check it out. Anyways, bye for now. So I hooked up my motor with some Lego. We found some old Lego around the house when I was a kid, and built this little structure to hold the motor. So I should be able to, now I can play with the code or do whatever and have it run. I don't have to hold it, which is nice. I'm gonna set up some more parts, I think, with the Lego, or try to anyways, and see how it goes. But this is good now. Able to hold it there. Coo. So I got it working. Got the tachometer working a bit better. Messed around with the code, and now it works better. I'll go over it in the on the computer. But so you have, please press button to start. Button. Reading RPM. See if I can do this. User mode, I guess. So you can. Please wait. 24 RPM, which is just arbitrary. You know, because it's not actually anything moving. But so I have this. Infrared emitter. And then the receiver, I put them on lead so I can kind of test it better. So now I got the temperature and humidity sensor working, which is pretty cool. So it 22 degrees Celsius and 34%. Pretty standard, pretty dry. But here's the DHT11 temperature and humidity sensor. But seems like a practical use out of it actually, so it's a pretty cool project. Might build one actually. Build one to actually use it, which would be nice. Yeah. Today I have proximity sensor hooked up. You see the doesn't really see, but I have the ultrasonic proximity sensor, and then it says how many centimeters it is, and then also meters. With this, 0.09 meters, 7.82 centimeters. Here, 1.45 meters to the ceiling, I guess. See if I can get the. There you go. Yeah, you can see. Yeah, that's what I was working on today. Pretty cool, pretty cool. So here's the electric motor circuit. And yeah, so this is what I built and I showed in the earlier. Electric motor, diode, transistor, and resistor. What I understand is a transistor is a way to control it, like a switch, but you can use it through the code depending on it. So that's how you can switch. And the diode, obviously it can only go one way, but I don't know why or how. So I know how, but I mean, I don't know why, I guess. So this is where I found just this in the codes here. So I got the code. And here's the code. So here are the functions. Here's what they call the functions. And then here's each function. And how I had problems because the wrong function was being called. So I figured out that they are called here, and you can just comment out and which one you want, which one you want, and yeah, and go from there. And up the tachometer code that I found from another blog tutorial post, and so I just put it in and then tried to use it, but it didn't work at first. So I played around with the circuit and the parts and the hardware, but I finally, oh yeah, It got it working better, but it still didn't work. So I thought it was the code. So I kind of troubleshooted a lot of this. So I thought if I put in a for loop right here to count, and I could display every time it fired, like the infrared. Well, actually, first I did it. It would read out like censored activated. I had it, and well, I think I'll just write it. It was while digital read, and this one is sensor. And then LCD. And I had just that, so then it would fire, and I had a LCD clear here. So it would read RPM, and then I would fire it, or like click the engage the sensor, and then it would say sensor activate. So I knew, okay, well, I got something there. So I put a for loop in here, but then I realized that the function that's being called here to record the time variable, and then it calculates RPM, is here, but then I noticed it had two for loops with a J, nested for loop. I was driving around figuring out later, I was just thinking about it, and I was like, oh, it doesn't be a nested for loop. So I took it out, and voila, it worked. So I show it in the other part of the video, but you fire it, and then it says like an arbitrary RPM. So I have the code here for the temperature and humidity task I did, and I ended up getting this from two different sort of tutorials, and there were some problems with it, and I finally figured it out. The first problem is that this include didn't work, and the one tutorial had in lowercase, and then the other tutorial had uppercase. But what I ended up to do was manage libraries, and then you this is how I figured this out from Googling, and go here, search it, and then it's installed. Oh wait, where is it? This one. So it's installed because I installed it, but that's what fixed it. Let's close this, and then the functions I was using, it didn't have the brackets here, and it still didn't work. I found that, and then I found you need to read in front of it, and then I kind of mixed some of it, and see how this stuff has a bunch of like in Fahrenheit and blah blah and different. So I just use this. So it reads out on the screen, LCD that prints, so it works really good. And then it finally worked, and that was it, and it was great. So yeah, seems simple, but going through it, there's some problems, but got it figured out. Anyways, thanks. Okay, I have a light monitor set up to the Arduino, and I got this plot. So if I turn the flashlight on, you can see the fluctuation in the plot. So this task I found on for my class, my microcontroller class. He uploaded a document that had all of them, so I was like, oh, I should go through them. He hasn't posted his own lectures of it though, but I found some of it online too. But this code is just examples, analog in out serial. Uploaded it, and then tools, serial plotter, and then that's really it. Change it up, Yeah, pretty cool. Pretty cool.